So now today's major heading is modulation. And modulation में जो हम सब टाइप पढ़ेंगे, that is AM modulation. Fine. But you first write, yeah, AM is amplitude modulation. You are exactly correct. So, but you first write a definition of modulation. You always remember till you read last. Okay. So, modulation. It is the process in which modulation definition हम लिख रहे हैं. This should be very clear, centered in your notes, centralized, clear, very bold. It is the process in which one of the parameter of the carrier wave parameter so I repeat, it is the process in which one of the parameter bracket में amplitude, frequency or phase of the carrier wave will be varied. आज की हेडिंग है मॉड्यूलेशन, ठीक है, नेक्स्ट पेज पे लिखिए मॉड्यूलेशन will be varied linearly in accordance with message signal amplitude variations. It is the process, I'll repeat, listen to me, anyone who arrived late. It is the process in which one of the parameter bracket में लिखेंगे amplitude, frequency or phase of the carrier wave will be varied linearly in accordance with message signal amplitude variations. In accordance with message signal amplitude variations. So this means that the carrier wave is actually modulated with respect to amplitude variations of message signals, such that these amplitude variations of message signal is preserved in the carrier wave, and from the demodulation side we actually will have a method which will reconstruct or extract these amplitude variations from the carrier wave, and we get the actual message signal back again. Is that okay? Quite logical? Because any signal is nothing but amplitude variations. So if we are somehow able to transfer the amplitude variations into some parameter, which can be the amplitude of the carrier wave, then becomes amplitude modulation. So if I am varying the frequency of the, eyes on board please. If I am varying the frequency of the carrier wave, that becomes frequency modulation. Do you get the point? So that means जो भी हम कोई पैरामीटर एक कैरियर वेव का वैरी करते हैं, accordingly the name of the modulation is set. So now the heading becomes amplitude modulation. Can you write the definition on your own? हाँ, लेकिन वो दूसरी टाइप ऑफ मॉड्यूलेशन बनेगी. वो एक जनरल डेफिनेशन थी जो हमने लिखी, अब हमें अलग अलग डेफिनेशन लिखनी है हर एक. नाउ वी विल गो फॉर इट इज द प्रोसेस इन विच द एम्पलीट्यूड, यू कैन राइट एम्पलीट्यूड मॉड्यूलेशन की डेफिनेशन जरा आप खुद से लिखिए. अगेन वेरी इंपॉर्टेंट डेफिनेशन. ओके, बोथ दीस डेफिनेशंस आर इंपॉर्टेंट इन द 5 and these So amplitude variation, it is the process in which the amplitude of carrier, very nice, will be varied linearly in accordance with, I'll repeat, amplitude modulation की definition. It is the process in which amplitude of carrier will be varied linearly. Because बाकी सारी definition same रहेगी, खाली एक word change हो जाएगा. पैरामीटर की जगह एम्पलीट्यूड यूज करना है. ओके, रिमेंबर दिस. फ्रीक्वेंसी मॉड्यूलेशन की डेफिनेशन आप बताएंगे फ्रीक्वेंसी मॉड्यूलेशन डेफिनेशन. ठीक है, आप देख रहे हो मुझे? आप so will be, it is the process in which amplitude of the carrier will be changed or varied linearly in accordance with message signal amplitude variations. मैसेज सिग्नल एम्पलीट्यूड वेरिएशंस हमेशा सेम रहेगा, वर्ड ना, खाली ऊपर वाला पैरामीटर चेंज होता जाएगा विद रिस्पेक्ट टू डिफरेंट मॉड्यूलेशंस. एम्पलीट्यूड वेरिएशंस. कैन यू जस्ट रिपीट, एवरीबॉडी प्लीज लिसन. जरा आप बताओ क्या लिखा आपने. आप जरा बोलो जोर से, क्या लिखा आपने? जोर से, हाँ सुने जरा.
Modulation can be defined as a process in which the amplitude of the carrier will be varied linearly in accordance with message signal amplitude variations.
हर एक ने ये लिखा, समझ आया? किसको समझ नहीं आया रेज योर हैंड. समझ नहीं आया? हाँ, समझ नहीं आया? आप मुझे देख रहे हो? समझ आया? हाँ, नहीं आया? कोई नहीं, आपकी आंखें वो बता ही नहीं रही हैं. ओके, एनीवेज, नेक्स्ट पॉइंट आप लिखिए इसमें. सिंगल टोन AM मॉड्यूलेशन. सिंगल टोन, इसकी नेक्स्ट हेडिंग सिंगल टोन AM. व्हाट डू यू मीन बाय AM? जो रेडियो स्टेशन हमारा होता है ना, AM क्वेश्चन फ्रीक्वेंसी दादा सा AMS क्या फ्रीक्वेंसी असा रेडियो स्टेशन नाही सगळं FM तुझं ना 92.7 FM कोर्स रेडियो जॉकी ना है के साथ क्या साथ 92.7 FM, that is why it is FM frequency. It is station, and you hear FM station very clear than the AM station. By that you should understand that the efficiency of an FM signal is better than AM by default, right? AM station जो है वो होता है आपका 102.6 शायद है. हाँ, इस रेडियो आकाशवाणी कहते हैं हिंदुस्तान की, क्या बोला है? Anyways, heading is single tone AM signal. So let's assume. Now you will write fast and you will write with me. Assume M of T is M of T equal to AM cos of 2 pi FCT, and this happens to be the message signal, rather a single tone message signal, because उसके अंदर FM यहाँ पे है. Eyes on board. AM cos of 2 pi FM of T denotes that it's a message signal. Another signal as C of T, that is denoted as AC cos of 2 pi FCT, that happens to be the carrier signal. Then finally the modulated signal will be given as S of AM of T. Okay? So C of T, M of T combined they form a modulated signal. Yeah. How do I do this? If I make this using a block diagram, suppose this is M of T and I give it another signal by the name of C of T. What it generates is S of AM of T. This is an AM modulator. ब्लॉक डायग्राम एक छोटी सी फिगर होनी चाहिए जब आप एम को डिस्कस करें आपके आंसर्स में एग्जाम में ये छोटी सी ब्लॉक डायग्राम्स एंड ऑल दैट दे शुड बी देयर बिकॉज दैट इज व्हाट मेक्स अ गुड आंसर. Into cos of don't divert the attention of the class please. Keep quiet. अरे यार देखिए जी. So now the modulated signal is, if you just forget this part, what is this signal by the way? ये वाला signal क्या है? Carrier signal. Eyes on board please. What is this signal? Carrier signal. But you cannot see the amplitude part. Right? What I said, amplitude modulation क्या होती है? हम कैरियर के एम्पलीट्यूड को लीनियरली वैरी करते हैं विद रिस्पेक्ट टू मैसेज सिग्नल एम्पलीट्यूड. यहाँ पे आप जो देख रहे हो वो वही है. कैरियर के एम्पलीट्यूड को एक मल्टीप्लाइंग फैक्टर मल्टीप्लाई हो रहा है और फ्रीक्वेंसी के साथ कोई छेड़खानी नहीं है. So this happens to be the amplitude modulation because what I am changing is actually the amplitude of the carrier with respect to message signal amplitude variation. We understand that once you are trying to multiplying something with something, वही चेंज हो जाएगा. ये वाला फैक्टर ऐसे देता है. ठीक है जी? ओके, we get my point. बट देन इससे कुछ फर्क पड़ेगी. अल्टीमेटली हमें एम तो ये है कि मॉड्यूलेट फ्रीक्वेंसी पे फर्क आए बिकॉज तभी तो वो मॉड्यूलेशन कहलाएगी. बिकॉज वी सेड मॉड्यूलेशन इज नथिंग बट एक्चुअली फ्रीक्वेंसी ट्रांसलेशन. इस फ्रीक्वेंसी पे तो लेटर ऑन इफेक्ट आएगा. बट to start with, we actually focus on the amplitude of the carrier signal that is being varied with respect to message signal. Okay, moving on, if I just expand this expression, so your S of AM of T, if I expand this in a different way, is AC 1 plus KA AM. अगर मैं आपके M of T को expand करता हूँ, cos of 2 pi FMT into this part remains same as it is जो ये था. You can write where KA into AM is equal to mu. That is very important term. I will KAAM जो यहाँ पे ये चीज है is equal to mu and mu is very important term. Modulation index. Okay. AA is amplitude, sensitivity of AM modulator. Huh? So this is point number 1, point number 2, point number 3. Mu into 100 gives me percentage of modulation, or we call it depth of modulation. Yeah, modulation depth. So our final expression for AM happens to be AC 1 plus mu cos of 2 pi fmt into cos of 2 pi fct. Are you done with this? I am at this line currently. यहाँ पे हूँ. अब मुझे ऊपर फिर से जाना है. मैं erase कर रहा हूँ. ऊपर वाला erase कर रहा हूँ. हाँ? इतना ही erase करो. Okay, now let me continue from this expression. ये आप देख रहे हैं. यहाँ पे एक cosine signal. Eyes on board, please. यहाँ से आप एक कोसाइन सिग्नल दे रहे हैं. आई विल मल्टीप्लाई इट विद दिस एंड AC को भी अंदर लाएंगे, AC को यहाँ भी लेके जाएंगे, cos को यहाँ भी लेके जाएंगे. The end result is this. So the final S of AM of t is it visible in this? Huh?
Yes. Not yes.
शीश लाग. सुना ही क्या? Okay. So S of AM of t is AC of I need your attention over here. AC cos of 2 by fct plus AC mu cos of 2 by fmt into cos of 2 by fct. Next is using formulas of sine and cosine which I leave to you. आप मुझे यहाँ पे एक फॉर्मूला लिख के देंगे cos of A into B is equal to what and all that. ये आप लिखेंगे अपने नोट्स पे. I want to see that tomorrow and मुझे कल का भी कुछ देखना था ना. वो क्या था? Okay, just show me that after this. So, as I expand this, oh, okay, Parna see it. Parna next step see. So, as I expand this S of A M of t, it will look like something like this. This part remains as it is. AC cos of 2 by fct plus. Now I will use cos of A dot B formula over here, which will result in AC mu by 2. ठीक है, mu by 2. Cos of this part and this part gets combined. FC plus cos of 2 pi. 2 pi FC plus Fm of t Okay, plus AC mu by 2 cos of 2 pi fc minus fm of t. So कक्ष बराबर है cos of a plus b. It is actually equal to cos a plus b by 2. Yes. You can manage it yourself.
सर पर आगे cos A cos B
कौन सा वाला?
जो अपने cos A
हाँ सॉरी. मगर उन फॉर्मूला थी कुछ जल्दी cos of a into b, cos a cos b, ये सारी फॉर्मूला दिखेगा तो साइड में आप लिखेंगे, उससे हेल्प हो जाएगी क्लास में सर. So what we analyze is, as a result of this multiplication, or I would say variation of amplitude, we have attained something. What is that something? We had a frequency f of c that is being shifted to another band fc plus fm, and we have one more band in fc minus fm. So you can write an AM signal and an AM signal. What do you mean by AM signal? Amplitude modulated signal. That is this signal. Contains, and AM signal contains, फिर colons लिखेंगे, colons, and AM signal contains. First thing, this part. It has three parts. The carrier frequency component. Eyes on board. AM signal के अंदर तीन चीजें हैं. एक है आपका carrier frequency component, because this as it is the carrier wave है ना, ये तो carrier wave का हिस्सा है, ना ही इसके amplitude में कोई variation है, ना ही इसकी frequency में, तो ये तो carrier फिर से आ रहा है. Second part is upper side band component. It has three components. First component is the carrier component itself. Second component is the upper side band component. Third component is the lower side band component. Now why do I say upper and lower? Because eyes on board. Because upper side band component has a frequency higher than fc, and how much higher? By fm. Lower frequency has a lower frequency. How much lower? By minus fm. So that's why the plus wala version is called as the upper side band. Minus wala will be called as lower side. You get the point? So what are the three parts? Right now. Okay, so this is something like that. We have two wings and a head. So head is maybe the carrier, and the wings are the upper and the side band, which are symmetric actually, which carry almost the same information. Okay, but as you can see, the information will be contained in only those signals which have the FM component, right? Information किस में होगी? उस वाले component में होगी जिसके साथ FM associated है. Eyes on board. Information उस component के साथ associated है which has the message frequency component, right? So doesn't this show me clearly that I am unnecessarily transmitting a part of which is the carrier directly, and which carries no information at all? I'll repeat. The information is carried in those components which have the frequency component of the message signal. Which is that frequency component? Huh? Huh? Badi pa mana? नहीं दूसरा से जाए एनीवे, आप उसको जगह छोड़ो एनीवे वेदर ही इज राइट और रॉन्ग, आप इस साइड से करें, ठीक है। which is near आपस में उसके स्कूल में जो जिदार की वॉर्ड दी और जरा इधर एक्सट्रीम पे चलो, बेंच एक्सट्रीम पे चलो, बस बस आप I said that the information is stored. तुमका बोझा मेल का फ्लैश बैच तुम खोली थोड़ा जोर से, हाँ. It is very good question. It is single tone with respect to the message signal. We have only FM1. मैंने आपको last time कहा भी था, when we talk about single tone and multitone, we talk in terms of message signal frequency. इसमें चूंकि message signal frequency का एक ही component है, so that is why this is single tone modulation. आया समझ? Had it been that I had FM1 and FM2, then it is dual tone. Now if it is FM1, FM2, FM3, FM4, so it is multitone. Rather FM2, if I have two components, even that is multitone. So, okay. The message is contained in only those components of this ISM board. The message is contained only in those components of the amplitude modulated wave which have the frequency of the message signal, or which carry the frequency component of the message signal. Which is that frequency component? FM? FM1 or FM? Let's keep it FM. So that means this part, which has only the carrier frequency, is an unnecessary part, isn't that? This means, this shows me itself that a good amount of power, you just write. However, it is clear from this, it is clear from the modulated signal itself. Write faster please. However, it is clear from the modulated signal. That an additional carrier, an additional carrier component is transmitted as a part of AM modulated signal, Therefore, a large amount of power will be wasted because of this component. ठीक है? Therefore, a large amount of power will be wasted because of whose component? Unnecessary additional carrier component जो है, इन terms को याद रखें, इनको सीखिए. Additional carrier component wastes power. Okay? Now we will see later on how much power it wastes. It wastes a large amount of power. Therefore, the additional carrier part wastes a large amount of power. Okay, Zwa? It wastes power. Okay, remember this. How much? You will tell me later on. How much power? You will tell me later on. Now the most important part of this particular lecture is the spectrum. So you write the heading, spectrum of AM signals. हालांकि इसके साथ ही है, लेकिन फिर भी आपको पता होना चाहिए हम क्या बता रहे हैं. So the heading is, everyone be clear. Heading is spectrum of AM signal. Jala, what do you mean by signal? Spectrum. Sorry, what do we mean by spectrum? No, I need you to be cautious. I cannot accept that. You cannot play with the words. Okay, what do we mean by spectrum? Any other definition? What is the definition of spectrum of a signal? No. आप क्या बुझता दोल बुझना सोच रहे हैं. हाँ बताइए. Any other? What is the definition of spectrum? आप बताइए. Yes or no? Mansa. What is the definition of spectrum? Very nice, excellent, that is the right answer. The definition of a spectrum is, once we come to know that which frequencies are present in a signal, we are able to identify the spectrum. Anyways, now we can clearly see in this particular signal, we will learn actually how we draw the spectrum. We can see here we have three parts, right? We have three parts. So this is the 0 point. अभी आप ना लिखे तो बेहतर, बस देखिए. We have three components. So this itself tells me that we will have three parts of the spectrum. The first one being present at a frequency that is Fc, and that is this component. Okay? But if you remember, this is a cosine signal. Cosine signal में कितने exponentials होते थे? कितने होते थे? दो. तो एक आता था Fc पे, दूसरा कहाँ आता था? Minus Fc पे. Excellent. Done. So this shows me that it is symmetric about the origin. Maybe I'll shift the origin so that it is exactly at the center. Okay, next point. Now I have something called as Fc plus Fm. Fc plus Fm. Is it higher than Fc or lower than Fc? Higher than Fc. So I will just arbitrarily identify some point which is like Fc plus Fm, and I make a small little peak over there. Why is the amplitude of this higher than this? Can you tell me? Because this has only AC and this is AC mu by 2. Something in division, and mu is also less than 1. Yes, mu is generally less than 1. So that's what it makes it even more lower. So, but once I have something at Fc plus Fm, यहाँ पे कहाँ होगा? यहाँ पे इस साइड से होगा. Okay? You will make a line like this. Make a line like this so that they coincide. समझ आया? यहाँ से इधर से होगा बड़ा नेगेटिव होगा. क्यों? क्योंकि Fc plus Fm, जिसका पॉजिटिव कंपोनेंट आएगा उसका मिरर इमेज नेगेटिव कंपोनेंट भी आएगा. हो गया ये वाला. अब आपका तीसरा है Fc minus Fm. Fc minus Fm जाना. Fc minus Fm will be towards right or towards left? Shabash, both sequence in it. But of same magnitude, this will be towards the left. So I will write Fc minus Fm because this is a frequency lesser than Fc. Okay? Now I need to go to the left side. Fc minus Fm. So this will be minus Fc minus Fm. Right. Generally you will not see it like this. You will see maybe किसी ने minus sign अंदर ली होती है. So instead of this, you can write or minus Fc minus Fm, and here also or minus Fc plus Fm. Now this one was upper sideband or lower sideband? This one. This is upper or lower? So name it as USB. And which one is upper sideband here? This one. USB, right? Huh? This component belongs to upper sideband. So even its mirror image will be called as upper sideband. Even though उसकी frequency आपको लग रही है on the lower extreme negative है, do not bother about that. Okay? Likewise, this belongs to the this component belongs to the lower sideband, and lower sideband is which one? Okay? And this component over here is nothing but the carrier. Yeah, असली नाम है additional carrier. Now the most important point. ये वाला कंपोनेंट किसकी वजह से है? ये वाला कंपोनेंट किसकी वजह से है? AC cos की वजह से। eyes on board, eyes on board। ये वाला कंपोनेंट किसकी वजह से है? इसकी वजह से। जरा आप फिर से बताइए। आप नहीं, आप क्या आगे बैठे? इसका एम्पलीट्यूड क्या होगा? एनी गेसेस? हाँ? नो, एनीवन एल्स? आप बताइए, आप बताइए। आप बताइए उसके आगे। आप बताइए। हाँ, आप बताइए, आप बताइए। नो, AC by 2, because if you remember cos को जब एक्सपैंड करेंगे ये दो एक्सपोनेंशियल से डिवाइड बाय 2 आता है, 1/2 इधर आएगा। क्या हो गया आपको? So it is AC by 2. Boys, now you tell me again. इसका आगे AC by 2, इसका क्या आएगा? इसको देखो, AC nu by 4। nu है ना एम्पलीट्यूड का हिस्सा। हाँ,
ठीक है सर।
अच्छा, उसका वैल्यू लेस देन मानो, लेकिन मैंने वो एज्यूम नहीं किया। राइट, ओके, लॉजिकल। बट मैंने वो मत पुट किया, मैंने फिलहाल इसको देखना। यू आर राइट। So I think that is done. AC by 2 is amplitude है, AC nu by 4 is amplitude है, and these are different frequencies, and this happens to be the frequency spectrum. Because in frequency spectrum, I need to know the amplitude of each frequency component. Number one. Number two, I need to know where those amplitudes exist. I have identified both of these things, and this is what we call as a frequency spectrum. Sure? So this. ये से बना क्या है? मान कुछ नहीं। Wait, so can anyone tell me what is the bandwidth of the signal? Raise your hands who can tell me what is the bandwidth of the signal. Think for a while. Think for 5 seconds. 5, 4, 3, 2, 1. Raise your hands who can tell me what is the bandwidth of the signal. No, I just want to raise your hands who can tell me what is the bandwidth. Raise your hands. Raise your hands who can tell me what is the bandwidth. Come on, 1 to 3. Okay, you tell me. How do you find? Stand up, please. How do you find that bandwidth? ना थोड़ा जोर से क्या? Exactly correct. Sit down. He is correct. Isn't he right? Why have you forgotten the general formula? Though your final answer is incorrect, but you have used the right formula. So, my dear friends, if I ask you to find the bandwidth of the signal using the general expression, what we find is this. That's the highest positive frequency minus the lowest positive frequency. What you are using the lowest negative frequency. That's the problem. You have to use, so the bandwidth, next heading actually is bandwidth of AM signal is equal to, bandwidth of AM signal is highest positive frequency. What is that? FC plus FM minus lowest positive क्या है? What's your name? Lowest positive क्या है? जोर से, शीशे टूटने चाहिए। हाँ, हाँ? 0 was in that case because we didn't have any other frequency component. But here we have a frequency component just before 0. So this you will take as your lowest positive frequency component. Are you getting my point? Any confusion? What is the general formula? The general formula is the highest frequency component minus the lowest frequency component. In previous cases, we had only the one frequency component, which has to be the highest. But here we have other frequency components. So we used to take by default 0 because there was no other. Here we have a component, so we will take this one as our lowest क्या? Lowest positive. Not lowest. Lowest is this then. Lowest positive. So lowest positive is FC minus FM. So FC minus FM is my lowest positive. When I expanded FC plus FM minus FC plus FM, FC and FC cancels out. What remains is 2 times FM is the final bandwidth of AM signal. जितनी बार आप बस बोलोगे उतना मैं आगे बढ़ता जाऊंगा. Let me decide when it is overflow. I know when it is overflow and when you cannot understand. Have you understood this? Yes or no?
Yes, sir.
आपने इसे पहले लेकिन बस बोला था, right? Very good. Next heading happens to be power of AM signal. Okay? We have done the 3 headings. First is representation or please जरा ये express ये लिखो. पहली heading जो थी very important heading यहाँ पे मैं भूल गया. Derivation of heading है derivation of general expression of single tone AM signal. Okay? The first heading that we started with when we started with the definition of modulation and all that, and then we started single tone AM. The heading there should have been derivation of general expression of AM. दूसरा derivation of general expression of AM signal, because that's very important. Then second heading क्या थी? Second heading थी spectrum of an AM signal. Third heading थी band. Fourth heading है power of an AM signal या total power of AM signal. Total power of AM signal. I am writing total power of AM signal. Okay. In order to find the power, I know that I have how many components? Oh, unfortunately, I just erased that. But I had the carrier component, I had the upper sideband, and I had the lower sideband. क्या सही? So that means total power PT will be sum of PC, power because of the carrier component. I will put this plus power of sidebands. But when I try to expand it, it becomes PC plus P upper sideband plus P lower sideband. Come here. In order to find the power of the carrier, we need to know the amplitude of the carrier component, right? And that amplitude happens to be how much?
PC by 2.
PC by 2. So, calculating PC. कैसे निकालेंगे हम? Is it visible in the camera? PC, हाँ? PC के लिए we have PC is equal to Vm square, maximum value of the voltage, divided by the 2R, which is the general formula, or the maximum amplitude actually. If you focus on this part, unfortunately मैंने वो erase किया, लेकिन आपकी notebooks पे है, ठीक है, उसको देख लीजिएगा. So as I try to solve this, what I will get is AC square by 2R. कैसे? Vm का वैल्यू जब मैं पुट करूंगा ना AC by 2, तो वो बनेगा एक्चुअली AC by 4. 4 and 2 आपस में कैंसिल आउट होके नेट रिजल्ट ये आएगा. आप यहाँ पे Vm का वैल्यू पुट करेंगे इक्वल टू AC by. So this is the equation 1.
So अगर VM को AC पे put करेंगे तो VM पे AC पे 8 आ जाएगा.
नहीं आप सॉल्व करो एक बार. Right. Vm is equal to AC. Okay, right. हाँ, because ये इसका नहीं है. We are calculating about this one. You're right. We are calculating the power because of the carrier component only. So Vm is equal to AC because that is what the expression tells. ठीक है? R is actually the antenna resistance, which can be taken as 1. And R is antenna resistance, which can be taken as 1. Okay. अच्छा ये मैं एक्सप्रेशन क्यों यहाँ पे यूज कर रहा हूँ? बिकॉज यहाँ पे लिखेंगे बिकॉज P DC is equal to Vm square by 2R, है ना? DC पावर का जो एक्सप्रेशन होता है Vm
normally we are square by r, फिर two
Right.
stop.
कुछ जरूरत नहीं बट
फिर AC by 2 space में आया AC. हाँ, but which one is after 2 नहीं.
दिशा VM में आज वो जनरल एक्सप्रेशन टेस्ट हुए VM को हम पुट करेंगे AC by 2
फिर ये आएगा AC square by 4
राइट
When is the password?
Okay, let's resolve it on tomorrow, but let's move ahead to the next part. P upper side band is equal to what? So let's expand one. अगर यहाँ को समझ आया जाए so it is AC square mu square by 8R P upper side band and चूंकि side band जो है side band